My name is Kenyatta Washington, and I teach at East Feliciana High School in East Feliciana Parish. As an educator, I am most passionate about bringing the mathematics to life for my students and incorporating STEM and engineering practices into the lessons as well. The grade level students in the video today consist of 10th, 11th, and 12th graders. The lesson being taught today is linear systems in 3 variables, and the curriculum is Eureka Math. The objective for today's lesson is the student will be able to solve linear systems in 3 variables algebraically. I prepared the lesson by reviewing solving 2x2 systems and the 3 methods for solving systems, which are graphing, substitution, and elimination. This lesson will help students understand and later be able to analyze 3x3 systems using matrices in pre-calculus and advanced mathematics topics. The students in my classroom are predominantly minority and come from different levels of learning. To support all learners, I have students to share ideas and concepts with their set partners and also compare and contrast their results. I have saw this class grow tremendously by working with partners and as working as whole groups as well. Determine the value of x and y in the following systems of equations. You choose which method you want to use. Graphing, substitution, elimination. You decide, and you can work with your shoulder partner.
You gotta plug it in with the first equation.
Yeah, I did.
You plug it in?
Yeah. I put it in like on both. You plug it on both of them? You just plug it in on this one, right?
Yeah.
You have,
Okay.
you have one.
You gotta like subtract 2 right there.
I mean, you had 2 for your one.
Yeah.
And then you did 2x plus 3 times 2. And then you got what equals 7, so you did 2x plus 6.
What you did?
Subtract 6 on both sides.
Yeah, subtract that. Put over there.
Subtract 6 on both sides. And then you go to this equation and plug your 2 in, your y to your y side for your next equation to be x. You want to do all this? You just subtract it on both sides.
Why did you choose the method that you chose?
Because I just found it more easier.
Why?
It was easier to count out the x's.
Yeah.
It was easy to cancel out the x's by using what?
Elimination, multiplication.
For the first problem?
Wait, what?
So elimination, multiplication for the first problem. Who agree with that?
No, I didn't do multiplication, I did elimination.
Yeah, elimination.
Subtraction.
Elimination, subtraction, why?
Because them like the 2x, the two x's, they are the same operation, so I have to turn the second 2x negative, so it'll cancel out and I can complete the rest of the equation.
Multiplication. Because,
You can't cancel none of them out.
right, we don't have duplicated coefficients and variables. We actually have negative 2y and positive y. So if we multiply equation 2 by positive 2, then it would give us our what? Positive 2y, right? So now when we combine them, we have what? Set your new system.
Right.
You have 5x minus 2y equals 4. And then we have
Negative 4x.
And negative 4x
Plus
2y is equal to 4.
and now we can do what?
Cancel out the negative 2y and 2y.
And 5x minus 4x gives us
X.
plus 0 equals
8.
8. So X is equal to
Eight.
Why did we use multiply the second equation by 2 to eliminate y? Why did you all want to eliminate x?
Because it would have been simpler to just both have to multiply both equations by a number to get the same number.
That's right. We would have to multiply equation 1 by
2.
yes.
And then equation 2 by 5 to get 10.
So that will require us to have what?
More steps.
First step. What was the first step?
The first step was to eliminate z from equation 1 and 2.
By which method?
Subtraction.
Okay, then what?
Then we replace it with equation 1.
Okay. And that resulted in what?
Negative 2x plus 4y equals 6.
Okay. So we know that our goal is to find 2 equations and 2 unknowns, right?
Yes, ma'am.
So how will we do that?
We have to eliminate z from equations 2 and 3 by adding the variables.
Okay. And once we do that, what are we going to do?
Replace the equation with the
Which equation?
4x minus y minus z is equal to -1. And we're gonna add that by x plus 4y plus z equals 12.
Which results in?
5x plus 3y equals 11.
Okay. So we're gonna replace equation 3 with the result, right? So our new system of 3 equations and 3 variables now has 2 equations with only 2 variables in them, right?
Yes.
So these two equations now give us a system of 2 equations and 2 variables, which we kind of reviewed in exercises 1 and 2. At the end of today's lesson, the lesson objective was met because as I monitored students and listened to their responses, the feedback was accurate and they also were 90% proficient on the exit ticket. If I had to do anything differently, I would incorporate more than one activity for the student that is lower than the majority of the class, and also have a more detailed discussion of solving 3x3 systems. After this teaching segment in the video, I plan to have students complete a project on 3 variable systems and create 3-dimensional models.